Hello, this is Mr. Best. Welcome to Chapter 7, Homework Questions 119 to 125. Question 119. The diagram below shows three bold segments. Find the coordinates of the midpoint of each segment. So let's just start with segment A here. And we can look at the ordered pairs, but since these segments are horizontal and vertical, we're really just curious about the X and Y coordinate, depending on which one we're looking at. So this one goes from 2 to 7. So we want to go halfway in between 2 and 7. The difference is 5, so in between would be 2.5. So therefore that would be right around 4.5. So it's 2.5 from 2 and 2.5 from 7. So since these ordered pairs are at 7, 3, then the midpoint of this one would be at 4.5, 3. So the midpoint of line A would be 4.5, 3. All right, for B, same idea. This point down here would be at -3, -1. This point would be at -3, 4. So we know the midpoint is going to be at -3. The difference between the 4 and the -1 is 5 again. And so we just go 2.5 in each direction. So if I add 2.5 to -1, that would give me 1.5. So the midpoint for line B is -3, 1.5. Alright, and then for segment C, this would be the point -2, -2, and then over here, this would be the point 5, -2. So we need to find the midpoint between the -2 and 5. So that would be 7 total units, so we need to go 3.5. So 1, 2, 3.5. 1, 2, 3.5. So you can see it's right in the middle there. And so if we add 3.5 to -2, that would give us 1.5. And then, and then the y value stays at -2. So the midpoint of C is 1.5, -2. And there are some other ways to look at the midpoint of each of those, but just in terms of what was talked about in class, trying to find that distance and then dividing it by 2 and then adding that to the coordinates, or subtracting, depending on which way you're going. Question 120. Are the triangles in this diagram similar? Justify your answer using similarity transformations. So the triangles SRH and SKA will be similar because you have a congruent angle. Angle S on both of the triangles, and then you have your right angle, H and A. And so therefore by angle similarity, we know that the triangles are similar. So that's kind of our justification there. Part B, and what happens is it does say using transformations. I guess the way that we do this is by a zoom factor, or we can dilate from that angle and just use a dilation. And we actually know what the factor is because so it's by a factor of 2, because this length is the same as this length, so it would be 1/2 for that one by using that similarity transformations. Part B, what is the relationship between HR and AK? HR, which is right here, HR and AK. Well, we just said the dilation was by a factor of 2, or the zoom factor is 2. So HR and AK, that means that 2 times HR would be equal to AK. The next one, between SH and SA. So here's SH, and then the whole thing is SA. So twice SH is equal to SA. And then the last one between SH and HA. So SH and then HA. Well, those are going to be the same because it has that factor of 2 there. So therefore this one would be SH is equal to HA. Part C. If SK has a length of 20 units, so SK is 20 units and RH is 8 units, what is HA? And so if SK is 20, then each individual part, since they are congruent, would be 10. We're looking for this distance right here, but we know it's congruent to this one. So let me get rid of a little bit of that. So once again, this is the distance we're looking for, but we know it's congruent to SH. We can find SH because we have a Pythagorean, we got a right triangle, so we can use Pythagorean theorem. It is one of our Pythagorean triples, 6, 8, 10. If you didn't know that, that's fine. Just use your Pythagorean theorem. So therefore, if SH is 6, then HA will also be equal to 6. Question 121. Examine the spinner below. Assume that the probability of spinning a negative 8 is equal to that of spinning a 0. So before we get started, let's just take a look at the spinner. We have a 90-degree angle, so this would be a fourth of the circle. The 6 would be half of a circle, so that's 1/2. And since negative 8 and 0 have the same probability, then, half of 1/4 would be 1/8. And so that splits it up. So if you add all four of those numbers up, you should get a value of 1. Part A, find the spinner's expected value if the value of region A is 8. So remember, to find the expected value, we're going to take the probability values, so 1/8 times the value of that region, plus 1/8 times the value of that one, which is 0, so that will just cancel out, but that's okay, plus 1/2 times 6, and then if region A is 8, then that would be 1/4 times 8. So that looks like that would be -1 plus 0 plus 3 plus 2. So we get an expected value of 4. So that's what we would expect if region A has a value of 8. B, find the spinner's expected value if the value of region A is -4. So really we're going to get the same thing, except we're going to change this last one right here. So I'll write that out again just so you can see. 1/8 times -8 plus 1/8 times 0 plus 1/2 times 6 plus now 1/4 times -4. So now we'll get -1 plus 0 plus 3, and then the last one will be plus a -1. So now the expected value when A is -4 is going to be a value of 1, which is still on the positive side. Part C, what does the value of region A need to be so that the expected value of the spinner is 0? Alright, so let's kind of set that up just like we have been. We have 1/8 times -8, so that's not going to change. We have 1/8 times 0 plus 1/2 times 6, so those all three we know, plus 1/4 times A, which we don't know what A is, but we want the expected value to be 0. So we'll set it equal to 0. So that's -1 plus 0 plus 3 plus 1/4 A is equal to 0, or 2 plus 1/4 A is equal to 0. So then we can subtract the 2. So 1/4 times A is -2 multiplied by 4. And A needs to be equal to -8. So if region A is equal to -8, then we'll have an expected value of 0, which then means it is a fair spinner. Question 122. For each pair of triangles below, determine if the triangles are congruent. If the triangles are congruent, state the triangle congruency condition that justifies your conclusion. If you cannot conclude that the triangles are congruent, explain why not. Alright, so on part A, we see that we have angle CAB. So what you can see on the picture right away is that angle A and angle E are congruent. You see that side CA and side CE are congruent. And then we also know that angle DCE and BCA are also congruent because of vertical angles. So by angle, side, angle congruency, we know that triangle CAB is congruent to triangle CED. Alright, on to B. Triangle CBD is congruent to what? Let's see what we have here. We have CB is congruent to EF, We also have BD is congruent to FG. And then we have a right angle F is congruent to angle B. So therefore, by side angle side congruency, we know that triangle CBD is congruent to triangle EFG. C. Triangle LJI is congruent to which triangle? So let's look at what we're seeing here first. Went the wrong way. LJI. So that's the triangle we're looking at. What triangle could it be congruent to? Well, we see this side length right here is congruent to just this one right here. So maybe this is the other triangle we're trying to prove that are congruent. So this one you can see is congruent to this one on the red one. We also have this angle J, which is corresponding to both of them. So we have a side, we have an angle, and then what else do we have? We have this little marking here where LK and HI are congruent. Is there a way that can help? So it might be hard to see, and maybe we need to separate these triangles, but if you look, this length right here is on the red triangle. So this length right here is congruent to this one, which is on the blue triangle, and those are congruent as well. So it does appear that the triangles are congruent by angle, side, angle. Sorry, I said that wrong. Side, angle, and then this full side here. So by side, angle, side, it does appear that they will be congruent. Angle L will match up with angle H. So we're going to go from here. Angle J is going to match up with angle J. And then there's the I will match up with K. So triangle LJI is congruent to triangle HJK. Once again, kind of getting rid of some of this stuff so you can see the triangles again. We are looking to prove LJI, this triangle. So you can see once again how this has those two lengths, that triangle compared to HJK. And so once again, see how this side has the two markings on it and this one has the one. That's what we used. All right, moving on to D. Triangle PRQ is congruent to triangle what? Well, angle P matches up with angle S. You can see angle Q matches up with angle T. And then angle R, or PRQ and SRT, but they match up as well. But we don't have anything about side length. So if we only have that the angles are congruent, we know they're similar, but we don't know that they are congruent. So this is one that we cannot conclude that the triangles are congruent, and that's because we don't have a side length. All we have is angle-angle similarity. All right, so make sure you do explain why it is not congruent, and I just wrote on here because the congruent angles is not enough information to prove. Question 123. For one of the parts A, B, or C for problem 122, create a flowchart or a two-column proof for your conclusion. Remember to start with the given facts and to provide a justification for each step. So I went ahead and did a two-column proof on this. We've been doing a lot of flowcharts, so I went ahead and set it up again. We have the statements, which angle E is congruent to angle A, and line segment CE is congruent to line segment CA. Those were given to us. And so then the other thing that we found out when we did this problem is that angle DCE and BCA are also congruent by vertical angles. So we'll write that down. We can't just say angle C. We got to make sure we're using 3 letters on this one because there's multiple angles at that point. So we will go with angle DCE is congruent to angle BCA, and that is because of vertical angles being congruent. All right, and then now that we know that, we actually have enough information to say that the triangle, so we'll go with triangle DCE, is congruent to triangle BCA. Oops, I put angle. Let's fix that. I was reading from the one above. So triangle BCA. And we know that because of the angle, side angle congruency. So it says for one of the parts, I just went ahead and did A, but once again, you could do B or C on this, and you can use a flow chart or you can use a two-column proof. Practicing both of them is a good thing. So that ends it at least for that part A. Question 124. Carolina compared her proof to Penn's work in problem 7-113. Like him, she wanted to prove that if AD was parallel to EH and BF is parallel to CG, then A is equal to D. So you might need to go back and look at question 113, but that's what we were trying to prove. So unfortunately, her statements were in a different order. Examine her proof below and help her decide if her statements are in a logical order in order to prove that A is equal to D. So let's go through and see what we have. So first, AD, line segment AD, is parallel to EH, and then line segment BF is parallel to CG. That's given. Then A is equal to B, and we know angle A is equal to angle B because of them being alternate interior angles, so that's good. Angle A is equal to angle C by substitution, but I'm not sure what we're substituting at that point, so we can't say that angle A and angle C are congruent because there's nothing to substitute just yet. So something seems to be wrong here, so let's start that one. Let's look at 4. B is equal to C. So, move those again. B is equal to C. Do we know B and C are congruent? Yes, we do, because those are corresponding angles. So that's good. It appears that these two actually need to be switched, because if this is true, if B is equal to C, then you can do your substitution and say A is equal to C. So as of right now, I think 3 and 4 need to be switched. Let's take a look at 5. C is equal to D, which is true, because those are vertical angles, so that looks good. And then A is equal to D because of substitution, which I think as well that should be good, that A is equal to D because you are substituting from up here. If A is equal to C, then you can replace C with A, and A is equal to D. So substitution would work there. That seems fine. So it appears, from what I'm looking at right now, it just needs to be 3 and 4 need to be flipped. And then everything else looks like it's good. Question 125. Describe the minimum information you would need to know about the shapes below in order to identify it correctly. For example, to know that a shape is a square, you must know that it has 4 sides of equal length and at least 1 right angle. Be as thorough as possible. So with a rhombus, we know it must be a quadrilateral, and we also know that all 4 sides have to be an equal length. A square is also a rhombus, so even if it's listed as a square, it has to have at least 4 equal sides. And if it does that, then we know for sure it's going to be a rhombus. For B on a trapezoid must have 1 pair of opposite sides that are parallel. So if it has 1 pair of opposite sides that are parallel, then whatever happens after that is fine. Then it would be a trapezoid. And so as long as those things are correct for the rhombus, 4 sides of equal length, and a trapezoid, 1 pair of opposite sides are parallel, then you know for sure that they will be at least that.